You almost need somebody to come out of the box and say, well, hey, what if we didn't have brakes at the corners? Do you need cast iron at the corners now? Could you put some other disc material in there that helps you out? So some of those traditional stuck in the mud ways need to be challenged moving forward.
This is Coffee Break. Today I'm with Greg Vyletel, VP of Engineering and Quality for PowerStop and the Chair of SAE Brake. I'm Brian Hagman. Let's go. All right, now, so you spent your whole entire career in the friction segment. You're currently the VP of Engineering and Quality for a well-known aftermarket company, and now you also help run one of the, I guess, the biggest brake gathering in North America. Seems like a really huge undertaking. Why try to juggle both?
Yeah, first of all, Brian, thanks for having me on here. For me, this has been such a great industry. I've spent my entire career here and met many, many wonderful people. It was, for me, one way to give back to the industry that has blessed me so much. The other thing, in all honesty, we have a great board and a wonderful technical team of volunteers that makes a lot of the lifting easy. I think most people will be shocked at how many people are behind the scenes making this thing work to be the great event that it is. So it may be a title and that, but it's the volunteers and the folks behind me that are the ones that really deserve the credit. So for everybody that volunteers for the Brake Colloquium, a big thanks.
What pulled you into the friction segment to begin with? I mean, was it deliberate or did the brake industry just grab you?
Ford Motor Company funded most of my PhD work, and I spent a bunch of time at their research labs in Dearborn. And then after graduating from the University of Michigan, Ford had an open position in advanced vehicle technologies working on friction materials. I really didn't know anything about it, but it was kind of a cool materials related industry. And I was like, and I somehow managed to convince them that my scientific process and know-how could help them out in that role. So they extended a role, and it's been a fun ride since then.
So at the Brake Colloquium, if you're there, room full of engineers, which hat are you wearing now? Are you wearing PowerStop's hat or the whole industry's?
That's a great question. When I hit the stage for like opening remarks or leading a panel discussion, it really is kind of a representative of SAE on behalf of the industry. When I'm walking through the exhibit hall, it's really a combination of SAE and PowerStop. I try to visit every vendor out there and just say thank you for supporting the industry, because it's the vendors that really make the event. But I also keep an eye out for technologies that are going to help PowerStop. So it's a good balance between the two, and it's a lot of fun for me. It's great seeing such good friends.
So I want to talk a little bit about friction just as a craft in general. A brake pad has to do a ton of different contradictory things at once, like, stop hard, stay quiet, got to spare the rotor, survive serious heat. Like, how do you begin to even balance that as a formulator?
See, that's what's fascinated me about this industry. And for me, it all goes back to first engineering/material science principles. People that have worked for me in the past know that I love breaking complex challenges into much simpler problems and working on those to deliver. So you kind of build and you say, okay, what's the most important? Is it NVH? Is it durability? Is it performance? My favorite phrase is there's elegance in simplicity. Folks that have worked for me will know that statement gets repeated a lot. And that's kind of the formulation side. If you take and try to get every one of those corners or every one of those nooks maximized, you're not going to do well. So you've got to kind of look and say, okay, this is a pretty good, well-rounded material. Where do I need to improve it? How do I improve that without degrading the other properties of that aspect of the formulation or the material? So it's been wonderful. And material science is the perfect background for that, because it's big into structure property relationships.
So like out of all those demands, I guess characteristics too, of the pad, like which ones fight each other the most?
It really depends on whether you're designing for the OE or the aftermarket. For the OE, it's always about zero noise. I can remember in my earlier years, we were running a LACT vehicle test when vehicle tests were big. And I remember specifically, we had one noise event out of like 250,000 stops. And the the engineering manager goes, what are we going to do about that? I'm sitting here going, okay, this is just insane. From an actuary perspective, there's no way you're going to treat one noise event, but they've got a different set of criteria. They've got JD Power numbers to worry about. They've got warranty to worry about. For the aftermarket, it's really kind of balancing affordability with performance and NVH. Most of the time, it's focused around NVH. I think as time evolves and some of the challenges, NVH is always going to be there because that's what gets people back. But now with the Euro 7 and some of the pending emission laws, I think you're going to see a focus more on the tribological wear and the durability issues.
When most people take a look at a pad, they just think of the pad as a pad. They don't put much thought into it. But what would surprise someone about what's in it? What's in an actual pad?
The biggest thing that people are not going to realize is the amount of materials that go into it. Way back in the days, and asbestos was just fading out when I started my career. So semi-mets were the big material. And then when I started at Ford, the first NAOs, non-asbestos organic or slash ceramics were being introduced. And I was blown away when you look at the reverse engineering on these. You see a semi-met maybe 8 to 12 ingredients. And then you get into an NAO or ceramic and you see 20 different materials that go into it. And you sit there and you go, what are all these needed for? And then the other complex thing is within those, for instance, and if you've got alumina, there's so many different types of alumina. So somebody says, oh, it's an abrasive or a friction modifier, but there's degree of calcination, there's percent alpha, there's percent gamma, there's the particle size. There's so many different things that go in there. So there's a lot of science and a lot of knowledge on individual raw materials that one needs to have to be a good formulator. And they're so different. You've got the phenolic resins that are for more chemistry slash polymer based people. There's the minerals and some of the ceramic fibers or mineral fibers that go in there for more of a ceramist or a true materials guy. So it's super complex. And I think the vast number of ingredients in there, I think, would surprise a lot of people.
Yeah, this is just something I just thought of too from a material perspective. Where does cost play into that? Is it a balance too about trying to find materials that are lower cost, but then obviously it has to perform. So how do you, just as an experienced engineer in the friction world, are you always having to kind of fight that as far as trying to find materials that work that are less expensive than others?
Yeah, you try to balance it out. There's some things that you sit there and you say, I know I will never touch this specific raw material, and this is the grade that we've used, and this is the grade that we will always use. And then there are other materials that you sit there and you say, okay, I can find this out of a different location. The current situation around the globe with when COVID hit and now with some of the current administration policies, you've got different challenges with logistics that in some cases, really the logistics drive more of the cost than the actual raw material. It becomes a good balancing point. There's always pressure from a purchase price variance to figure out how to get lower cost raw materials without sacrificing. But then that's where it gets really complicated because you think that these two materials are exactly the same, and then you put them in the formulation, and that's the only thing that changed, and the material behaves completely different, even though the materials aren't there. So it gets into how people specify. There's a lot of chemical specs out there that don't really fully cover the full impact of the material simply because people either don't have that knowledge or it just gets overly burdensome to put a spec on that and yet still have people that can meet that particular raw material spec.
This episode is brought to you by Hagman Search. When it comes to finding top-tier talent for your executive team, Hagman Search is a name you can trust. Not simply a recruiting firm, it's your strategic partner. Go to hagmansearch.com to learn more. All right, so now the EV curveball. So EVs barely touch the friction brakes, with the regen braking. So what does that do to the pad you're designing? And where do brake dust and Euro 7 come in all this?
This is an interesting, it's still in a learning experience, I think, for a lot of people, because most people have a traditional system design spec that they found did not adequately predict some of the failures that have evolved with electric vehicles. For instance, the corrosion removal, the lukewarm or cool friction, and some of the contamination issues. There have been solutions for it where some people have said, oh, we're going to look at FNC, ferritic nitrocarburized disc, or something to avoid the corrosion aspect. Some folks have looked at doing applies, just brake applies at set intervals to try to remove that. Some folks have even be surprised because when they park their car after driving in the winter down a salty, slushy road, there's no latent heat from the motor to melt any of the ice contamination that can build up at the wheel corner. So then you wake up the next morning and you've got this big, huge lump of contaminated ice and debris around the wheel. So I think people are looking at or finding out that there are unique challenges to the EV world. And then the whole Euro 7 and potentially pending CARB activities, that's really kind of dramatically changing the industry because in addition to just the friction side, you see a tremendous amount of brake rotor research on coating, advanced coatings and how to minimize wear and people are putting plasma coatings on. The FNC's doing well in that arena, but everybody's trying to figure out what's the best mousetrap for the next industry issue.
Speaking of like Euro 7, it's the first rule to put brake particulate on the table. Is that really changing how we're formulating, or is that kind of overblown?
I mean, the simple answer is yes, it is going to change. It is, however, a very interesting challenge. I think people traditionally with the friction guys, the friction material manufacturers, it's always been everything related to the friction material. You picked a platform or 3 or 4 platforms. If you were developing for the OE, it was the specific whatever new vehicle you're designing for, and you just use that particular rotor and you just assume that, okay, how do I meet their requirements? Well, now with some of these rotor coatings that are coming out, I think you're going to start to see some either partnerships or some development where you've got to develop it as a true friction couple as opposed to focusing just on the formulation side of it. Because on some of these plasma coatings, and I've played around with them in the past, looking for anti-wear, it's essentially a formulation. You can put hard materials in there like titanium diboride, tungsten carbide, silicon carbide, et cetera, that are anti-wear. But now you've got a formulation for the plasma coating, just like you would have a formulation for the friction material. It's a simpler formulation because there are fewer ingredients in it. But if you are doing a plasma coating or something like that, or a high velocity impact coating, you've got the CTE, coefficient of thermal expansion, mismatch between the gray iron and that coating. So you've got to kind of have a buffer layer in there that helps protect from cracking of that coating. I think you're going to see some changes in the approach. The other thing people don't realize is somewhere, depending on the formulation, 20 to 60% of the formulation, the raw materials going in are PM10 or below, simply because a lot of the friction modifiers and that in there are small particles, because if they're not, they're just going to chew up the rotor and make it essentially a grinding disc or a grinding pad. You've got a lot of very fine particles that go into the formulation. It's going to be an interesting ride over these next 3 to 5 years and seeing the technology that comes out on rotors and rotor coatings.
I guess in your opinion, or from your experience here recently, is the aftermarket ahead of OEMs on this or behind? Or are both segments kind of working on this hand in hand?
It's really a complex problem for the aftermarket because with EVs, we don't have decades experience like we do with ICE vehicles. And like the OEs, we're still learning in the aftermarket the unique challenges these vehicles present, because the OEs get vehicle feedback because of the durability that you end up with and the longevity of the pads. Where you would typically see a vehicle come in for a brake replacement at 4 to 5 years, with an EV, we're not seeing it for 7 to 10 years. So we really don't from an aftermarket perspective, we really don't completely understand that market. However, aftermarket companies like PowerStop and others, we're working on solutions that address those. That's one of the things that Brake Colloquium helps with, because we do hear some of the issues that people are experiencing with EVs and hybrids that you haven't seen out there. So it's one of the benefits, but it is complex, and both sides, the OE and the aftermarket, are still in that learning mode.
Yeah, and speaking of the SAE Brake Colloquium, that's a perfect transition because that's what I want to talk about next. For someone who's never gone to the event, what happens at the Brake Colloquium that simply can't happen over, say, a Teams call?
First thing, and probably for me, the colloquium provides an environment where you've got the entire supply chain at one event. You've got, if you take the OE side of the supply chain, you've got OEMs, you've got tier one brake suppliers, you've got tier two friction suppliers, and you've got all the raw material folks in there. From an aftermarket perspective, you've got all the, you can go in and have back-to-back meetings with your entire supply chain for raw material guys. And it's the face-to-face interactions that simply are not the same in Teams. You get a little bit of reconnaissance. You can see who's talking to who and kind of predict, okay, what's going on. So you get a little bit of G2 knowledge in there that says, hey, I saw these guys talking to these guys, and you can kind of see, oh, that's kind of an interesting relationship developing or discussion. You may not know what's going on. And it's the engagement for me, for a guy that's been in the OE and the aftermarket. It's good to talk to tier ones now that I've been in the aftermarket, to kind of stay up on what technology and what they're working on. It's also good to communicate some of the challenges that the aftermarket faces, because you've now got, I think we're up to 26 or 2,700 different D plates. And you sit there and you go, why in the world do you need 2,600 different D plates? So you sit there and you kind of see both, and it's a great opportunity to interact that you just can't do on Teams.
Yeah, so 44 years in, this is the 44th SAE Brake Colloquium Exhibition. Now, what's kept the motto, by engineers for engineers, from getting watered down?
It's interesting because there's an ever evolving landscape that keeps the colloquium from getting watered down. If you go back, as I pointed out earlier, when I started my career and attended my first colloquium, we were in the era of semi-mets transitioning to naos or ceramics, and the colloquium was geared toward a lot of the raw material friction industry. Then you started to get ABS and some of the technology into the vehicle, and now all of a sudden you went from purely a friction show to more of a true braking show, with people coming in talking about control strategies and some of the other stuff that goes on. And there's always something new on the horizon, whether it be regulatory, technology advances, market demands. That's what we're looking for, to incorporate those areas into the program. I think looking into the crystal ball, you've got a larger focus now on AI and emissions over the past couple of years. And I think that's going to continue to evolve moving forward.
Not to put you on the spot or anything, but I will. What's the best hallway conversation you've had, or maybe like any aha moments you've had while you've been at the colloquium? I mean, obviously, you spent your career in the brake industry, and you've been to several brake colloquiums, and now you obviously are helping to lead the brake colloquium. So, is there anything that comes to mind?
Yeah, for me, it's really not one single moment, but it's kind of almost like a time capsule capture. And you look at the different approach the emissions topic is taking compared to how the copper regulation evolved. And with the copper regulation, there's a very collaborative environment between Washington, California, SAE, the Brake Manufacturers Council, and MEMA. And you had industry, academia, and the government all working kind of side by side. The emissions topic seems to be markedly different. The industry hasn't been that engaged, at least in the US, hasn't been that engaged. And that might be because unlike copper, the emissions took root in Europe, and the U.S. is kind of lagging a little bit, trailing that play. But it's a complex challenge that needs input from all of these critical folks, because you need the power of academia to kind of do some of the work. Obviously, the government does what they're going to do, but it significantly impacts the industry. And I think they thought copper would be easy, and copper was easy up until the final portion of the regulation, where then people realized, oh, how do I implement this? So you almost, on some of these regulations, you almost kind of need to start at the back end and how would this be implemented, and then work your way back to the science side of things, because this has the potential to be tremendously complex. And I think the folks in Europe are starting to see some of that.
Yeah, and the 2026 program is literally right around the corner. It's coming up. What's the one thing you're most excited about at this year's event?
For me, it's really hearing about how AI is going to be into the design process and some of the advances and what people are doing with AI. I think AI is a bit overused, and there's some folks that if they do a DOE, they'll say, "Oh, this is AI," simply because it was kind of a numerical model or prediction. What I'd really like to see is true AI, where you kind of give a few parameters, like put something in on Chat GPT, and then it truly spills out an elegant solution. If you ask Chat GPT to come up with a friction formulation, it says, oh, that's a complex challenge, and those are highly proprietary, and it gives you something, but it really wouldn't be a friction material. And the other thing that's really interesting is the number of papers we've got on particle emissions, non-exhaust emissions.
Yeah, I got you. So, and speaking of like AI, like what percentage do you think of brake companies are actually trying to embrace it right now? Are we still really in the infancy, or do you think we've, as an industry, really kind of gone in on it?
I think the industry's going in on it. Again, I think it really, you kind of need to say, what do you truly mean by AI? If you said from an advanced AI perspective that, oh, I've got a 20-inch wheel, the vehicle weighs X pounds, and it needs to stop in this set distance, and I want to minimize the weight, maximize performance, give me a design. I don't think we're there yet. I think people are inputting stuff in and saying, okay, what kind of seal groove is optimal, and letting stuff go on that. I've seen some folks starting to get into the friction material design. I just scratch my head because we've tried some of this in my past with some pretty smart people, and you've got the variation of the dyno variation, you've got raw material variation, and the variation overweighs the granularity of the model. But I think eventually we're going to get there. It's just, what level are you happy with in terms of AI or numerical engineering versus something that you just say, oh, I don't need an engineer. I just type in a bunch of stuff, and away I go.
So, earlier in our conversation, we kind of mentioned, SAE Brake and who attends. We talked about the OEMs are there, suppliers, you got some academia there, even students. We've even got, a small group of students that go to the SAE Brake Colloquium. Is there any demographic or group that's not there that needs to be?
I'd like to see more of the OEs participate. I think there's tremendous advantage to having it. We don't see any of the aftermarket retailers or WDs coming in for that. And it may be out of scope for them because they may see it as being too technical and say, oh, well, I go to Apex a few months later, and that's more of my show, as opposed to kind of seeing what's going in, because they're just kind of buying friction. We always would love more students to come in, but I think the challenge there is the way academic research is done at the universities. There's not a lot of research on braking. So to send a student, they just don't know what they don't know. And you're not going to get a student from most US universities. There's a few that are doing brake related research, but the emission stuff probably will kick off and help us to generate a bit more student interest with academia. So OE participation, I'd like to see more purchasing people there. Some of the feedback we got from the vendors are the real decision makers and the purchasing people aren't there. We've got a purchasing panel this year that we're hoping to kind of seed plant a little bit with this panel to get some interest, and maybe let them see that, hey, there is some value in coming here, because it's kind of like a grocery store. You've got all your vendors at one place, and it's one trip for you to talk to 15, 20 different people.
Yeah, really good point. Before we wrap up today, I want to get your thoughts on kind of like, I guess, future outlook looking forward, like 10 years out? Like, what does the brake corner actually look like?
It kind of depends on how the EV hybrid electric powertrains continue to penetrate the market. And unfortunately, different administrations have different viewpoints. And when you try to force something down people, it usually doesn't end up well. You've kind of got to let free markets kind of roam to where and what customers want. I think you're going to see definitely markedly different disc technology at the corner to combat current and pending emissions regulations. If EVs continue to grow, I could see some OEMs eliminating rear brakes at the corner and maybe have one rear brake central into the driveline, maybe, or something like that, because you really won't need it. Probably one of the most certain areas I think will be is you'll see more dry systems and the elimination of hydraulic. You'll get into more brake by wire. I think that technology is coming. There's a lot of enablers that have been introduced with the hybrid electric, and that where you've got much higher voltages running throughout the powertrain, where a traditional 12-volt system on an ICE vehicle where 10, 20 years ago wouldn't have made brake by wire practical. But now you've got kind of different power situations that you can put those into.
What would be your pitch to a young engineer, or say even a student, about why the brake industry is the most interesting it's ever been?
We're at kind of a transition point. We've got so many different things going on. You've got hybrid electric, and the amount of braking that's done traditionally is going down. You need to be kind of a cross-functional, multidisciplined engineer, kind of a mechatronics guy. I think you're going to see a lot of data science come into play, especially as these AIs go in. And you're going to need to know something about the braking system. If you just go out to Silicon Valley and pull some computer science guy in and come say, hey, help me make my brake system better, they're not really going to know. So you're going to need to have some people that are really well versed and well rounded in the various engineering degrees. And I think that's a challenge for some of the universities moving forward, is instead of this mechanical engineering, electrical engineering, computer science, material science, you're going to need kind of some much more cross-disciplined degrees that really give new students out there. The other thing I think that's great is you really need kind of some new ideas to challenge the status quo, especially with EVs. Everything is traditionally, well, you need this because this is kind of the way we've always done it. And you almost need somebody to come out of the box and say, well, hey, what if we didn't have brakes at the corners? And what if we just had driveline emergency brake and we utilize regen and stuff like that, where you can go in. Do you need cast iron at the corners now? Could you put some other disc material in there that helps you out? So I think some of those traditional stuck in the mud ways need to be challenged moving forward. And I think that's a great place for some of the youth to do.
All right, last question here, or I guess offering to you. So, in your words, as the chair for SAE Brake, who should come to the colloquium, and how do they sign up?
Yeah, come one, come all, man. There's something for everybody here, from senior leadership to early career engineers. The technical presentations, exhibitors, networking opportunity offer something for everyone. And if you want to register, it's www.sae.org/events/brake. Love to see you out there. It's a wonderful venue. We've been there before. Not the easiest place to get to, but it is, once you get there, you'll truly appreciate it. And it's a great opportunity to meet new folks and reacquaint with others, and enjoy the fruits of the discussion.
Greg, I appreciate it. It's been fun. I've enjoyed our conversation. I definitely look forward to doing this again sometime.
Yep. Thanks, Brian. I appreciate your time.